Have you ever thought about how cool it'd be if we could, teach computers to see the connections between images taken with totally different kinds of cameras?
Hmm.
Like matching up a regular photo to an infrared image or even a thermal scan? Like how cool would that be?
Yeah, totally.
That's actually what we're diving into today.
Awesome.
The whole world of multimodal image matching. And we're going to be looking at this groundbreaking approach called MINIMA that's using synthetic data and getting some pretty remarkable results.
Yeah, it's a super fascinating area, this whole multimodal image matching thing. It's all about finding those pixel correspondences between two pictures, even if they were captured using, totally different modalities.
Right.
So think of it like teaching a computer to see the link between, say, like a normal photograph and an X-ray image.
Whoa.
And this kind of technology, it has the potential to totally revolutionize everything from 3D modeling and robotics to, medical imaging, the whole nine yards.
Yeah, so it's like we're teaching computers to see the world through multiple lenses, right? Like revealing these connections that maybe our human eyes wouldn't necessarily pick up on.
Exactly.
But I imagine that comes with its own, unique set of challenges.
Oh, you're absolutely right. For a long time, researchers were stuck relying on these handcrafted features. So it'd be like painstakingly designing algorithms to pick out specific patterns that were consistent across the different modalities.
Oh, wow.
But this approach, it was super time consuming and a lot of times pretty unreliable.
Yeah, I bet.
Then deep learning came along and things really started to change.
Okay.
Neural networks could automatically learn features from data, but they needed a massive amount of labeled data to train effectively.
I see.
And that's kind of where the challenge lies. Labeled multimodal data is incredibly scarce.
Ah, so it's like a data problem.
Exactly.
Which is where Minima steps in
Right.
with this innovative data engine.
Exactly. The brilliant minds behind Minima figured out a way to bypass the need for those vast amounts of real-world multimodal data.
Bro.
They realized they could harness the power of generative models to create their own synthetic data sets.
Oh, wow.
They started with, readily available RGB image data sets like Megadepth, which has millions of pictures of outdoor scenes. Using these images as a foundation, they generated pseudo versions of other modalities, like, infrared, depth, and even artistic styles.
Hold on. So they're basically creating their own training data.
Yeah.
That's some seriously clever thinking. But does it actually work? Like, can synthetic data really compare to the richness and complexity of real-world images?
That's the surprising part. It actually works incredibly well.
Really?
In fact, they found that their synthetic data often outperforms real data sets when it comes to training these matching models. You see, real-world data sets, they often have biases and limitations. Like, they can be unbalanced in terms of the types of scenes or objects they represent, or there might be inconsistencies in the way that the data was collected. Synthetic data, on the other hand, can be very carefully controlled to avoid these issues.
Oh, okay.
It offers more balance, more variety, and ultimately proves more effective for training purposes.
So they've essentially created a super-powered training ground for the algorithm,
Right.
free from all the messiness of real-world data. That's pretty mind-blowing. But tell me, how does Minima actually work? Like, what's the secret sauce that allows it to achieve such remarkable results?
Well, Minima uses a two-stage process. First, it pre-trains its matching model on a massive amount of RGB images.
Okay.
Think of it as like giving the algorithm a solid foundation in image matching 101, teaching it to identify patterns and correspondences in standard photographs.
So it's like giving it a crash course in visual literacy before throwing it into the deep end of multimodality.
Precisely.
Hmm.
Then in the second stage, the model is fine-tuned on the synthetic multimodal data. This is where it learns to bridge the gap between different modalities,
All right.
leveraging its pre-existing knowledge of image matching as a foundation. This two-stage training process allows for rapid convergence and excellent generalization to unseen modalities.
Okay, that makes sense. But let's get down to brass tacks. How good is Minima, really? Give me some concrete examples of its performance.
Okay, so the results are genuinely impressive. Minima consistently outperforms existing methods, including those specifically designed for single modalities.
Wow.
For instance, in a test on matching regular photos with infrared images, Minima achieved a 400% improvement over the best sparse matching method.
Whoa, 400%.
It even surpassed a state-of-the-art semi-dense matcher.
That's a significant leap forward. But wait, there's more, right? You mentioned something about zero-shot performance earlier. What exactly does that mean?
That's right. Minima also exhibits remarkable zero-shot performance. In other words, it can successfully match image pairs it's never encountered before. Imagine taking a photo with your smartphone, and Minima can instantly match to a thermal image, a depth scan, a satellite image, you name it. The possibilities are endless.
That's incredible. So we're talking about tech that could understand the visual world in a way that, we humans can't even fathom. But let's shift gears for a second and talk about like real world applications. Where could this kind of technology have the biggest impact?
Oh, definitely. The potential applications of Minima are vast and incredibly exciting. One area where it could be a true game changer is medical imaging.
Oh, yeah. Medical imaging is all about getting the clearest picture possible, and it relies on so many different types of scans.
Exactly. Think about like a doctor who's trying to analyze a complex medical condition, right?
Right.
With Minima, they could like seamlessly integrate images from a CT scan, an MRI, and a PET scan, creating a much more comprehensive view. This could lead to earlier and more accurate diagnoses, more targeted treatments, and ultimately, better patient outcomes.
Yeah, it's like giving doctors superpowers, allowing them to see the unseen
Right.
and make more informed decisions. That's truly remarkable. But what about other fields? I imagine this technology could have a huge impact on things like robotics and self-driving cars as well.
Absolutely. Self-driving cars, for example, they rely on a whole suite of sensors. Cameras, LiDAR, radar, each providing a different perspective on the surrounding environment. Minima could help these systems fuse this data together more effectively,
Okay.
creating a more robust and reliable understanding of the world, even in challenging conditions like fog or low light.
So Minima could be the key to unlocking the true potential of autonomous vehicles, making them safer and more efficient. That's like a game changer for transportation as we know it. But what about something a little more unexpected? Could Minima be used in fields like art analysis or historical preservation?
It certainly could. Imagine art historians being able to compare different regions of the same painting,
Wow, yeah.
revealing like subtle changes made by the artist over time, or even uncovering hidden details that were lost to the naked eye.
Right.
Minima could also be used to match damaged or fragmented artworks to existing photographs or sketches, aiding in like restoration efforts.
That's mind-blowing. We're talking about like bridging the gap between the past and present, connecting different forms of visual expression in ways we never thought possible. This technology has the potential to transform the way we interact with art and history. But before we get too carried away, I have to ask, are there any limitations to this technology? It all sounds a little too good to be true.
You're right to be cautious. While Minima offers incredible possibilities, it's important to remember that it's still a relatively new technology.
Right.
The researchers behind it, they acknowledge that there's still work to be done
Yeah.
in refining the synthetic data generation process and ensuring its robustness in real-world applications.
So it's important to proceed with a healthy dose of skepticism and to validate these findings with further research and testing. But even with those caveats, it's clear that Minima represents a significant leap forward in our ability to, understand and interpret visual information.
Absolutely. Minima is a testament to the incredible ingenuity of researchers in the field of computer vision.
Yeah.
And it's a powerful reminder that we're only just scratching the surface of what's possible with artificial intelligence.
This has been an incredible deep dive, and I'm sure our listener is as captivated by Minima as we are.
Yeah.
We've covered a lot of ground, from the technical details of the algorithm to its potential applications in a wide range of fields. But I think there's one more question we need to address before we wrap up. What does all this mean for us? How does Minima change our understanding of the world and our place in it?
Yeah, that's a great question to ponder.
Yeah.
We've explored all the technical marvels of Minima and its potential to like revolutionize so many fields. But what does it all mean like on a grander scale, What does it all signify?
I think Minima challenges us to reconsider how we even perceive the world around us. Like we tend to compartmentalize these different sensing modalities.
Okay. Yeah.
We treat them as separate windows into, reality. We see with our eyes, we feel with our touch, we hear with our ears. But what if there's a deeper, more fundamental structure that connects all of these seemingly disparate senses?
That's a fascinating concept. You're saying there's like a hidden language, like a unifying thread that ties all these senses together. Precisely. And I think Minima seems to hint at the existence of this underlying structure.
Wow.
It suggests that despite their, apparent differences, these various modalities, they share a common ground,
Mm.
like a hidden language that's just waiting to be deciphered.
So Minima isn't just about matching images, it's about uncovering a deeper connection between different ways of sensing and comprehending the world around us.
Exactly. And it's a powerful reminder that there's always more to discover,
Hmm, yeah.
more to learn, and that our understanding of reality, it's constantly evolving.
Man, this deep dive has taken us on a journey. We started with the intricate workings of image matching and ended up contemplating the very nature of perception and reality.
It's pretty wild.
Minima, with its innovative approach and truly remarkable capabilities, has opened up like a world of possibilities. It's challenging us to think beyond the limitations of our own senses.
Absolutely. I think it really underscores the incredible potential of human ingenuity and the transformative power of AI.
Couldn't agree more. This deep dive into Minima has been truly illuminating, and I hope you, our listener, found it equally insightful. We encourage you to, delve a little deeper into this fascinating world of multimodal image matching. Who knows? Maybe you'll be the one to make the next groundbreaking discovery. Until next time, keep exploring, keep learning, and keep diving deep.